Hello, everyone, and thank you for joining us for today's AM webinar, focusing on print, replace, and repeat distributed manufacturing with metal AM, sponsored by Velo 3D. Before I introduce your AM experts for today, I'd like to just run through a few things to help you make the most of the webinar. First, the link you use today will be available for 1 year to view the webinar back. It is being recorded and you can feel free to use it as many times as you like and to share with your colleagues. Second, we will have plenty of time with our AM professionals to answer as many questions as possible. If you look over to the left side of your screen, you should see an icon with a question mark. Please enter your questions there throughout the program, and again, we'll address as many as we can. And to kick off today's program, I'd like to introduce someone from the oil and gas area, Carlo de Bernardi, who is with Conoco Phillips. And
Yes.
Hi, Carlo. Thank you so much for joining us.
Thank you.
I have just a couple of questions for you about additive manufacturing and the supply chain before we get to the presentation. So could you tell us why you took on the challenge of, what were some of the factors, what made you decide to tackle the challenge of integrating additive manufacturing into your supply chain?
Yeah, absolutely. Very good question, and good afternoon, everybody. So the reason why I decided to start working on additive manufacturing, that was several years ago, because I stumbled into additive manufacturing by chance. So basically, I was visiting an OEM, an equipment manufacturer, and I noticed that they were assembling a very strange component, because with my manufacturing background, I realized that component it was just not doable in a traditional way. So I asked the question, how did you make it? And the answer was, that is 3D printed. So that is the beginning of my journey with additive manufacturing. And the reason why I decided to enter and to know more about additive is because at the end of the day, in my job, I'm an end user, I'm an operator of this type of equipment. And we want to make sure that what we are getting is safe, is reliable. And in order to make sure that it's safe and is reliable, we need to know what is going into the equipment that we buy and we operate. The other reason is because I believe additive can unlock a lot of potential in terms of more efficiency due to better designs of certain type of equipment, or a more agile supply chain. And we want to make sure that this value is passed through the entire value chain, and we are getting some of that value, that we are not just blindsided and reacting to the new technology.
Laura Lynn, I believe you might be muted.
I did a manual mute. Apologize, everyone. So, okay, Carlo, let me see if I can repeat that question. You hinted at it in your answer that using additive manufacturing will enable you to manufacture closer to the point of need, and hence, in essence, a distributed manufacturing system. Would that be one of the reasons you're looking at integrating AM into your supply chain?
Yeah, no, absolutely. I mean, we are all experiencing how painful are these supply chain disruptions, and reshoring manufacturing is not an easy task, especially when you're thinking about traditional manufacturing. So to make an easy example, you cannot move a foundry overnight from one country to another. And the problem is not really only about moving tools or making a big investment on expensive pieces of machinery, is also transferring the knowledge. So what additive is doing is combining together several steps, but not all the steps of the manufacturing process, and doing it in a compact and controlled way. So you need less capital investment if you want to start making things. And yes, we do need a certain type of skill sets, but is less problematic, most likely, to develop those skill sets than developing the entire set of skills that are needed to produce components in a traditional way.
That makes perfect sense. So based on your experience, Carlo, what are the biggest challenges you see to using additive manufacturing in your supply chain?
I would say that there is a set of technical challenges and a set of more commercial supply chain specific challenges. I will start from the technical challenges. So the number one challenge, like any other technology, is industry acceptance. Industry acceptance comes from industry recognition that the technology exists and standardization. So that's why the very first steps that we took as an industry in terms of adoption of additive were and still are about industry standardization. I'm chairing the API 20S task group. We are almost ready to publish another API document called API 20T for 3D printed polymers. Many other activities are happening into the standardization space. Once the standardization is, I'm not saying done, but the foundation has been laid down, the next thing is, how are we including, how is this technology fitting in the current supply chain model? The current supply chain model is maybe convoluted for certain aspects, but is very well established. So it's something that is almost going in cruise control. And we are disrupting with additive this current manufacturing model, because we are, again, combining different steps into one, and because there are new players coming in. These new players and this new technology, they are not naturally fitting in the landscape, manufacturing landscape that we have today. So we are trying to slowly modify the manufacturing landscape, but also to work with the new players, make them understood what their place is. So understanding what is the place of additive manufacturing in the current supply chain landscape is probably the most demanding challenge. Things like intellectual property are something that everybody's talking about. So again, what additive is doing is opening a certain potential, but also is perceived sometimes as a threat, because it's easier to reproduce something than with traditional manufacturing. So again, it's about what is the right place of the technology and how can that fit in the existing supply chain model.
Fantastic. Well, thank you so much, Carlo. We're going to turn over the program to the Velo 3D team to talk a little bit about the technology that's enabling a distributed manufacturing supply chain, including a case study. So I'd like to introduce and welcome S.J. Jones and Sid Raje. Program is yours.
Thanks, Laurelyn, and thanks everybody for having us here today. The live is streaming, correct? And I have control? Yes, maybe we'll find out. Okay, so welcome to Distributed Manufacturing with Metal AM. The three main things that we're going to cover today are: number one, what's required for distributed manufacturing; number two, a quick overview of the Velo 3D products; and then in the second half of our presentation, Sid is going to talk to you all about a case study around this specific application. So printing the same part twice is really deceptively easy. It's actually a more challenging thing than most people would think to consistently repeat the same part exactly from machine to machine and location to location, and then to also take that consistency and then scale it on like a massive set or a fleet of machines. So if it's that challenging, how are customers expected to be successful in serial production? And from serial production, that's how we gain more industry-wide adoption. So first, I want to talk about standardization, where the focus is really around part repeatability. So there's two ends of the spectrum for standardization. Number one is the industry level. So that relates to standards developed by industry bodies like SAE, ASTM, SME, those types of things. And then there's also the manufacturer level standardization, which refers to more site-specific standardization. Think more along the lines of vertically integrated OEMs or your local contract manufacturers that have some machines. So this manufacturer level standardization tends to describe workflows and processes that allow you to make the same part repeatedly. And when we refer to manufacturer level standardization, a lot of the times people tend to think about the QMS that a lot of these industries use to execute these manufacturing workflows. So the site-specific manufacturing certification is really challenging due to the architecture of a basic laser powder bed fusion system. This architecture that is more traditional allows for a lot of variability because it's very operator dependent. So if you have one operator who's more thorough than another operator and the machine is cleaned more thoroughly one time but not the next, then you do get some variability in how the part is made, which can impact your material characteristics later on down the line. And so a lot of the onus that we have for enabling this type of standardization at the site falls on the machine manufacturer. And for us at Velo, we feel that it falls on us to make a better machine. So we focus a lot on fleet standardization. Fleet standardization falls somewhere in between industry level and manufacturer site-specific level. A system from the ground up that creates an architecture specific and designed for serial production so that we can repeat our parts over and over and over consistently. And one of the ways that we do that is using controlled parameter sets. So we have revision controlled parameter sets as opposed to an open architecture that allows you to change and develop and tweak things like laser power and speed and whatnot. And with that controlled parameter set, you do get material validation that we also do and that we also do provide. And because of that, you're able to print a given part, the same part, no matter where you go. We have a golden build file, which is essentially what we provide. So like if you come to us, we create the golden build file, or you create your golden build file and we've checked it and certified that it's good. And that golden build file is just a set of instructions that can be distributed to any of these Sapphire systems geographically and executed to deliver the same end result. So this gets you a lot closer to standardization than what you can get with an open architecture system where you're allowed to play around with those parameter sets. So we brag that we provide the end-to-end solution. And I just want to clarify that we provide the end-to-end printing solution. At our core, we are a process company, and that's how we've developed our capabilities. And we've developed 3 tools essentially to make this process work. Number 1, you have our print preparation software. Number 2, you have our Sapphire tool. And then number 3, we also offer our assured quality validation software. So for the Sapphire printer family, we are a manufacturing technology company that was founded in 2014. We're also listed on the New York Stock Exchange. The Sapphire printer family is currently composed of the Sapphire, which is the normal size, and the Sapphire XC, which stands for extra capacity. And I'm happy to say that we now offer both of these in the 1 meter Z build height. The Sapphire family of printers all use the same software. We run the same processes, and we use the same materials to ensure repeatability and consistency across our fleets. These machines were made with serial production in mind. And so speaking of materials, most of our material releases have been driven by our aerospace and defense customer base. We've been very focused in the aerospace and defense sectors, but we've seen applications start expanding into heavy industries like oil and gas or power generation. And that's where this upcoming case study is actually focused. So in the heavy industries, we're seeing a heavy reliance on distributed manufacturing for maintenance, repair, and overhaul of their systems. The valves in this case study are a really good example of how you can leverage the distributed supply chain, printing geographically anywhere in the world. And with that, I'm going to hand it over to Sid.
Thanks, SJ. I am going to take a moment and take control. All right, so it's great to be here. Thanks for making the time to drop in on the webinar here. I'm excited to get into this. As SJ mentioned, I will be talking a little bit more about a case study that illustrates this concept of distributed manufacturing. And the way that we'll do that, right, is we'll talk about a specific application that we've worked with one of our customers, IMI-CCI in this case. And the part here that we looked at was the multi-stage trim valve. Essentially, that's what you're looking at here in this photo, and we'll talk through that as a case study on our distributed manufacturing topic. So a couple of things, right, about this multi-stage trim valve, right? The component itself, it's extremely unique in that it is a cylinder of metal, and it has, as you can see, a lot of tortuous paths that go from the ID of the part to the OD of the part. Essentially, the paths that you see there, right, provide good flow control in some very, very demanding oil and gas applications. Essentially, you have a very large required pressure drop across the part, and you need to be able to meter or control flow or fluid through this valve without having extremely high velocities that result in things like erosion, vibration, and noise, right? And the way that works is this component has a plunger inside of it that blocks and unblocks different levels as it moves through the paths so that the fluid can flow from the ID to the OD. So these types of valves, right, where are they found? They're typically in production, in the production space, right? In the oil and gas sector. So thinking power generation systems, nuclear plants, chemical refinement. So as you can imagine, right, the environments where these are operating can be very, very demanding. When you think about the legacy manufacturing process, right, for these valves, right, in traditional manufacturing, they're manufactured as disc stacks. So basically what you're doing is you start with a circular hunk of metal and you're either milling or plunge EDMing these paths into your discs. And then once you have a series of discs, right, you line them up and you braze a stack of these discs together to create a full part. And so, as is the case with any manufacturing process, there are some pros and there are some cons, right? On the cons side, when it comes to brazing, there can be challenges during post-processing, as well as during operation in some pretty demanding environments. As far as the pros go, right, these parts, they can be highly customizable. So the flow paths on the internals, they're optimized and sort of dictated by these very specific applications that are intended for different fluid viscosities, different pressure drop requirements, and things like that. And so at the end of the day, right, as you describe this part, you start to realize why, what unique aspects to this specific part, right, make them a great AM candidate. So for one, right, we see benefits when you go to AM with this component is you eliminate the brazing process, which can be a potential failure mechanism that impacts and reduces the lifetime of the product. You can customize these further, maybe build some more functionality into the part at a reduced part price relative to its complexity when you compare it with a conventional manufacturing path. And then most importantly, right, you see a lot of supply chain benefits because there are a lot of these valves that have unique flow paths for different applications, when you start to think about stocking them, right, that becomes a big challenge because this is a low volume, high mix part that you basically need to stock, right, for each unique geometry that's out in the field in service. And so this is exactly the reason why this part, right, is a great case study for us, Velo3D, as well as our customer, right, when it comes to examples of how AM and specifically Velo3D is enabling these concepts that we talk about related to digital warehousing and distributed manufacturing. With all that said, right, in terms of the great things and about AM and the benefits, you sort of have to talk about certification challenges, right? Production implementation isn't as easy as just printing a few parts. When you transition from a conventional manufacturing process like brazing to AM, that comes with its unique set of challenges. One of the major challenges, right, for AM specifically, when we talk about the heavy industry space, is that, you know, the requirements and the bodies tend to be very conservative, right? So personally, I come from an aerospace background, so I am familiar with that flavor of conservatism. But these requirements, I have realized, are quite different, right? In this industry, the geometries may not be overly complex, but the operating environments are extremely challenging, right? Some of these environments that include prolonged exposure to hot and corrosive chemicals like hydrogen sulfide. So because of that, right, these types of requirements have already been considered and vetted deeply, right, in this industry. And now you kind of have to do the same thing and reapply all of that to AM. So not only does the performance need to be tested, but we need to thoroughly vet our mechanical properties in order to qualify this part for service. So as I mentioned, right, we worked with IMI Critical Engineering for this part to run through a complete qualification for one of these disk stacks. So keep in mind that this is an ongoing study at the moment. So we'll be sharing quite a bit today, but in the coming weeks, we will be releasing some compelling data that speaks to the field performance of these parts over time, as well as the manufacturing process repeatability for these components when it comes to machine-to-machine repeatability at systems that are located at several contract manufacturers all over the world. So for this project specifically, right, we needed to meet our customers' requirements when it comes to the material qualification. In this case, it means the mechanical properties, right, and the corrosion resistance of the material that we're printing. The Sapphire qualification, or printing, you know, parts and coupons on the Sapphire platform per the requirements that are defined in API 20S, which is a standard that's released by API, or the American Petroleum Institute, that specifies the requirements based on part criticality that need to be met in order to qualify the AM process for metal AM components in the oil and gas industry. And then lastly, part qualification, which means that the part performs and functions per its design intent for that application. So starting with the material qualification, right? One key differentiator for Velo3D is that we are committed to doing a lot of the mechanical and material property validation for our metal AM process and providing that to our customers free of charge. We want to provide control parameter sets to our customers that are printing real parts, not just test bars and test geometries, and that these control parameter sets are tied to material properties that have been vetted by industry organizations that our customers rely on for qualification. And so in this case, right, for our 718 process, we are working with our customers to establish compliance with NACE requirements, which govern a lot of the corrosion susceptibility for components and make sure that you know, these parts are well suited to withstand a lot of these very high, I should say, harsh environments. And in practice, right, how do you do that? And the way that we're approaching it is through just rigorous amounts of corrosion testing. And, even though there isn't necessarily an AM standard for NACE, we're fairly optimistic that by going through the same testing as a conventionally manufactured part, we can achieve that NACE compliance for our AM process. And so we work with our customers to help define these test matrices and work through that. And then next, right, in terms of the Sapphire qualification, we worked with our customers per the API 20S spec to determine the criticality of this part and followed the appropriate requirements. So API, for example, API ASML or AMSL level 3, right? Or I'm sorry, I'll back up. API defines 3 different levels of criticality for a component, right? And the highest level of criticality, which essentially takes down, a well or leads to refinery to stop producing, is AMSL3. And so in order to, and that's the requirement that you set in stone and you start with. In addition to the AM component itself, right? For one of the first times in a production context, we were also able to test the API 20S standards by going through the full validation of the feedstock, the print process itself, and the post-processing and testing, all 3 of which are going to be critical to your qualification. At the end, right, we were able to show results that were very consistent with the traditionally manufactured part when it came to the flow rate of this valve as a function of plunger depth. And that's what is shown here in the bottom photo there. And basically what you're seeing is 2 different lines for performance where they're essentially right on top of each other, and they're telling you that that flow performance as a function of plunger depth. And you can see the outcome in AM is quite consistent with the application's requirements. In addition to that, right, we also like to share photos of that because, it makes it a little bit more real than just a flow plot in Excel. But what you're seeing there is on the left-hand side, the part, there's a photo of it going through mechanical proof testing, where essentially it's held in a vise and a force is applied to ensure that structural integrity. And then that's the same method that would be used for a brace component. So, we saw good results and a good outcome there. And then the photo on the right is the flow testing rig. So the part is fastened into that rig, and you see that various flow regimes are validated as a function of that plunger depth. So one of the key enablers, right, on our system that helps the qualification, the Sapphire qualification, is the Assure tool. And really, I think it's something that we don't talk about enough. Assure is Velo3D's quality assurance and validation software, and it provides a very in-depth look into calibrations, which is key when it comes to things like repeatability, especially when you're talking about digital warehousing and distributed manufacturing. Our machines can self-calibrate, especially in the optical system, which is something that we need. It makes this qualification process much more seamless. Assure also gives you an in-depth view into the build execution itself, which includes some of the key processing parameters on your build process that aren't necessarily available to the user with some of the other AM systems on the market. And one of those capabilities, right, is the one that you see there in that green sort of screenshot there. And that one's called Height Mapper. Essentially what this is it's a structured light scan that measures the topography of your powder bed, both before and after every recoat, so that you know what your powder bed quality is, where your parts are, and how they're behaving throughout your entire build. Finally, in terms of part qualification, right? as I mentioned, the parts that we're seeing here are in production per API 20S. They're installed in wells and accumulating use. We've seen some good initial results in terms of nominal performance. They're also seemingly showing better durability in terms of like longer life versus their conventionally manufactured versions. So, as I said, this is a snapshot of sort of an ongoing effort. So it seems promising thus far. But, earlier I mentioned, that follow on that we are doing, right? We're using that work to sort of build more depth into the part qualification system. I think we've seen some initial success, and we're optimistic that story just gets better with time as we accumulate more time in service for these components. But I think the more important takeaway here is that there is a way to get to scaled production when you start to talk about digital warehousing and distributed manufacturing with AM. And that's where we're working towards, right? That's where Velo3D is working towards that reality. And to kind of further that even more, right? I think overall, we're finding that it's not just applicable to printing the same part over and over, but in a case study like this, right, with IMI Critical, this is applicable to parts that have thousands of different part numbers in that same part family. And so from our perspective here at Velo3D, right, it's becoming a way to get scaled production when it comes to metal AM, not just across different parts, like I said, but even different part families. That's all we had on the case study. Laura Lynn, I'll transition it back to you for questions.
Absolutely. Definitely an interesting case study. And I'd like to also ask SJ and Carlo to join us again, and to remind our audience that you can use the icon with the question mark to enter your questions. We will get to as many as we can. So here's a question to kick us off, and anyone who wants to take this, please jump in. So speaking of questions, what's the one question that you are most tired of hearing on the subject? Where is the most confusion? What would you like? How would you like to answer it? So maybe you don't have to answer it again anytime soon. What is that question you get over and over again?
Can I go first? So for me, immediately what jumps into my head is the question of, do I need to print tensile bars? If you are making aerospace parts, if you're qualifying parts, if you're qualifying builds, the answer is yes. You should probably print some tensile bars. What about you, Sid? Do you see any questions that get repeated quite often?
Yeah, I think just around part qualification, I think the we talked through this a little bit, but one of the things that we always stress and want to stress, right, is the entire process is important. And while we emphasize the print process and taking the onus to standardize that, the post processing cannot be ignored. That's a whole part of this equation that that must be addressed and with a thoroughness.
Question is Flow compatible with conventional CAD software? Can it be used as an add-on?
Yeah, I can take that. So yes, Flow is compatible with conventional softwares. I'll say. I think you're just referring to CAD software, and that the way that Flow interfaces with CAD software is that Flow is a build setup software. So you import your native CAD geometries into Flow, and so one important distinction here is that we are not working with STL files. There's simply too much variability, when it comes to exporting and number of triangles and resolution differences, and that affects the process. So in order to eliminate that completely, we work directly with native CAD files and not STLs. But to answer the question, yes, it is compatible.
Terrific. Let's see, what do we have? Okay. And Carlo, I know you're newer to your AM journey, but I'm going to start with you on this next question. So, throughout the industry, as particularly at the AM Industry Summit, what did you see as the greatest advancements we've made so far as an industry regarding supply chain flexibility?
There's a great point. I would say that I am amazed by the speed of adoption and the rate of adoption of additive manufacturing within the OEM community in the oil and gas. I was visiting a few OEMs in the past few weeks, and most of them, they doubled down their efforts in additive, but they are also making 2-3 times the number of components that they were making 2-3 years ago. And when I say making, I'm talking about production. So one of the reasons because of that is happening is, again, supply chain constraints. So I know equipment OEMs that they are transitioning products to be 100% 3D printed, not because there is a specific advantage at the moment, but just because it's the only way to get them done in a reasonable amount of time today. That comes with challenges. So one challenge that I can see in the future is that the bottleneck in the supply chain can be moving from traditional manufacturing to additive, because the capacity is limited with additive, and it will be easy when you have an heavy industry like oil and gas that is opening the floodgate. It will be very easy to overwhelm the available capacity, not only in terms of printing capacity, but also in terms of powder availability. I mean, if there is a shortage of forgings when it comes to Inconel, there will be a shortage of powder if the demand is moving from forgings to powder.
Those are all great advancements and enabling flexibility. SJ, you were there with us in Long Beach with aerospace and energy industries. What were some of the things that you saw that are supporting flexibility?
So I was really happy when I was at the AM Industry Summit to notice that a lot more people are taking into account the full AM workflow. So it's not just the printing, but they're also taking into account post-processing, and people are now incorporating other facets of what it takes to convert to an AM part as compared to a traditionally manufactured part. So one of the big talks that I really enjoyed was about the true cost of an AM part, and how oftentimes we tend to not factor in to the cost of the conventionally made parts, how much it costs to transport them, to store them, to ship them all over the world, to ship them to the sites that they're needed at, or how much it costs in downtime if they don't have that traditionally manufactured part. None of those costs really go into the cost of a traditional part. It's just how much did it take to forge this. So if AM can get you a better lead time and prevent those downtime costs, if we can get distributed manufacturing and digital warehousing, and you can order your part from the closest geographical location and save all of that shipping cost, especially with the way the supply chain shipping is set up today, I think I'm just really excited for what the future holds.
Definitely, I think that's one of the things I've seen in the industry of you can't use the typical per unit cost when you're understanding the business case of using additive manufacturing. So Sid, before I go on to some more questions, are there advancements you've seen, whether at the industry summit or elsewhere, that'll help this flexibility of the supply chain for additive manufacturing?
Well, I think just broad strokes, right? I think Carlo hinted at it up front. What it takes is recognition of the technology and then standardization. And so, once, I guess from our perspective, we're working on the standardization part. And so I think that's going to be key, right? Is to have that standardization in place. And I think that's kind of the big thing that people are faced with in terms of challenges.
Well, having worked with AM standards early on and being a part of ASME, I have to fully support the value of standards in accelerating adoption and use. So we have a question that's come in from the audience about startups. So the startups obviously have a slightly different business model and different set of resources, but at Velo3D, do you work with startups who are driving innovation but don't necessarily have short-term commercialization routes yet? Can you share a little bit about how those collaborations might work?
Yeah, absolutely. I think the short answer is shoot me an email and we can talk. I think generally speaking, right, it's what we're looking for is, what is your vision with AM? How do you plan on using it? And I think, regardless of startup or not, right, if it's for the right reasons, I think it's at least worth exploring. And so what I mean by that, right, is you can generally tell from like the questions, right, is what path people are trying to take. Maybe, and I think we alluded to this a little bit earlier too, but if we're talking about, is AM the right path for me? And the way to answer that question is, does printing this one part that I currently make with conventional manufacturing, is that cost effective if I print it? And if that's the question that we get, right, it can be a sign that maybe, that vision isn't thought about in the right ways. And so rather than size of company, right, it's more of what are you trying to do with the technology, right? Are you focused on specific pain points? Are you focused on a broad sort of vision where AM enables a new technology, something that hasn't been done before? If those are the cases, then yeah, let's figure out a way to work together.
If I may, I would like to add something, just to make sure that the audience, especially people that are doing my job or something similar to what I do, we tend to talk about AM like one thing. AM is not just one technology. So don't forget that we don't only have laser powder bed fusion. We have DED, we have binder jetting, we have polymers. So we have to look at the entire spectrum, and each of these technology has its own space. So there are many applications that are probably not a good choice, for example, for LPBF, but they could be a perfect fit for DED WEM. And there are different challenges, different pros, and different cons.
So we have a couple of questions coming in, and I'm going to stay on the theme of standards for the moment. And are there existing standards in place that can be used as part of aerospace certification for AM components? Who would like to take that one on?
If we are speaking of oil and gas, I can definitely answer to that. If we are speaking about other industries, I can't.
Carlo, if you want to answer from an oil and gas perspective, I can certainly give a perspective from the aerospace side.
Yeah. So from an oil and gas perspective, yes, we have a foundation that is API 20S. That is a supply chain document. And so you understand, we started with the supply chain type of standard because we recognize that the AM, the main impact is on supply chain. That's why we have this conversation today. But what we are missing and we are working on are product specifications. there are hundreds of product specifications. I mean, we were talking about valves. There are a number of valve product specifications. Now is a matter of integrating additive manufacturing through API 20S into the product spec. It is a very, how can I say, challenging type of task. We are working on it as we speak. It's not going to happen overnight. And the reason why it's not happening overnight is because we do not have all the data that we need today to make certain type of decisions. So we mentioned also the NAEs. These days they change name is AMPP, but it's the same thing. All the requirements that are in that standard, they are coming from a number of failures, a number of incidents, even significant incidents that happened over a span of 30, 40 years. The industry learned from the incidents, the industry improved, and that's why we have this set of requirements in place. It is extremely difficult trying to just move what we have to additive manufacturing, just because we are building the baseline of data that are needed to make certain type of decisions.
And to kind of piggyback onto that, right, in the aerospace side, SJ alluded to at the top of the hour here, two different types of standardization, right? You've got sort of the industry level and then the site specific level. And so I think what we're seeing in aerospace is there are industry level standardizations that are out there that can be used and leveraged. But then the site specific is what takes, I'll say, a little bit more investment. And what we're trying to do is to standardize that to lower that barrier for our customers. So they're both required. It's just, I think fundamentally there seems to be this theological, like this sort of philosophical question of, you know, who owns it? And we're trying to take more of an ownership for it so that our machines and our systems are driving consistency and producing the quality monitoring validation paperwork that's required to then plug into an existing QMS or site-specific infrastructure.
And if I can just fill in some things on that, if you're looking for published standards, can recommend starting at the Additive Manufacturing Standardization Collaborative project between American Makes and ANSI. They regularly keep up to date on not only what standards are published, but also what the gaps are. And to speak to Carlo's point, what standards need further research. And you can also look at both ASTM, F42 that works with ISO TC 261. They do a lot of standards. And ASME also actually has a standard working group working on considerations for additive manufacturing and regulatory compliance and certification in aerospace. So specific to that particular question. So let's see, let's get a few more questions in here. I don't think we can ever have an additive manufacturing webinar without having a question on materials. So the question for the Velo 3D team is it possible to qualify new materials with the Velo 3D team? Are there any limitations for materials that may be used?
So generally, so the first part of that question, is it possible to qualify new materials? Yes. And the way that we approach new material qualification is when, let's say that a customer wants a system in an alloy that we don't have currently qualified. The development of that alloy, right, comes with the purchase of that system. So it's not like an additional consulting charge or anything like that. Now, when you talk about limitations, right, is it what are the limitations? Generally, the guidance that I provide is, if it's weldable or if it's being done on a laser powder bed fusion system already, it's probably going to be doable. There are some materials that are sort of inherently not fit for the process, and that's just kind of a physics-based limitation. So that applies here as well. But generally, if it's weldable or is being done in laser powder bed fusion, we can do it as well.
All right, so let's take a step back for a moment and talk about supply chains and additive manufacturing. And Carlo, I'm going to jump to you first. From your experience and what you've seen, are there any organizations or even industry application areas that stand out with their adoption of AM in their supply chain? And can you recognize or pull out any things they do that are unique that stand out?
Yeah, more than industry organizations, there are a number of end users in the oil and gas that are initiating collaborations. So I would mention the one that comes to my mind because we are working with them. There is a collaboration effort led by Equinor, Total, Shell, and ourselves, called Field Node. Field Node is about digital warehousing, and the scope of that initiative is basically not only to create a platform for a digital inventory of parts, but is to basically answer to the many challenges and questions, starting from technical qualification, supply chain, to enable the practical implementation of a digital warehousing concept.
And SJ, have you seen any organizations that stand out to you?
So I'm gonna have to pick on Relativity Space for a minute. I love what they've done with the whole like creating their own printer and their own software. It sounds very familiar. And how successful that, they've been with that, and how they understood the value of tying in the software with the printer under one house, under one roof, so they can iterate faster to make a better product. So if I had to pick someone in industry that I would really admire, it's definitely those guys. What about you, Sid?
I think, again, generally, I've seen a few examples, but maybe I'll describe what they tend to have in common, is that you have an engaged cross-functional team working across either one organization or multiple organizations. So I think, collaboration is a big part of it. And one of the more important portions, I would say.
Okay. We do have a question that came in, and I'm going to kind of reword it a bit because, SJ, you spoke to it a little bit. We talked about it. The question is regarding at what volume does it make sense to use AM parts for an application, 10, 100, 1,000? And you spoke earlier to some of the things that are decision factors on how you build a business case. And it's not always quantity. There are so many factors. Could you include kind of quantity and some of the other factors in making those decisions?
Oh man, that's a heavily loaded question. I'm gonna try and answer it in the short time that we have left. So when you're thinking like AM production and if it's going to make sense or not, you have to think about the size and the space that you have with which to do that, whether it's going to be done externally at a contract manufacturer or if it's going to be vertically integrated. And then you've got to think a lot about like the end final product and then work your way back to the printing. So you've got to think a lot about post-processing and like what's the optimal size to batch for post-processing so that I can build like the most cost-effective post-processing plan when I'm running into production. And then you come back to the printing and you have to think, okay, well, how many build plates can I store? How many can I have? How many parts fit on each build plate? What's the optimal set for machine turnover? So machine turnover is something that we don't tend to talk about a lot, but when the machine finishes the build, you want someone there to turn the machine over and get it started immediately, because downtime is lost time and lost money. So then you've got to optimize the build plates, and things like that tend to factor into the overall business case. But inherently, you've got to think about, does AM provide value in terms of performance, in terms of lead time, and how does that compare to the conventionally manufactured part, and how much that is worth to your organization? So that's my recommendation. Say, did I leave anything out?
No, I think you hit most of it. The only thing I would add is something that Carlo mentioned earlier is, working backwards, not just to laser powder bed fusion too, but what AM technology is right for your part. That can be a big driver too, especially when you start talking quantities, right? Where, when you talk about hundreds of thousands of parts, right? Maybe something like DED or binder jet or something like that might be right. But yeah, I think you got mostly everything.
If I may, I would like to add something, because it is an interesting question that you will have a different answer from different actors, different players. So from an end user perspective, is a matter of doing ourselves a better job in terms of evaluating the life cycle cost of something. So, for example, if I take a valve like the one that has been presented with a 20% better CV, I am basically producing 20% more on that production line. That 20% more with the oil at $100 a barrel is $20 a barrel more that I'm making. So on the flip side, what are the consequences in terms of downtime? So if downtime is an important factor for a contract manufacturer, you can imagine for us. I mean, there are examples of an entire platform that is down because a flow line is blocked, and that flow line doesn't work because a valve like that, the one that has been presented, is damaged. So every day we are talking about a few $1 million of production losses. So you can imagine that if we are losing $1 million a day, I don't care how much does it take to make this component. I just want to get it done now. So that is all part of the considerations. But definitely we as an end user, we have to do a better job in terms of estimating the real value of the components that we are using.
So I think that the answer to that question that's both simple and very complex is it depends. So we have just a couple of minutes left, but I want to get one more question in to all of you, because it's always good to look forward. So here's the challenge. In 30 seconds or less, what's next? So SJ and Sid, what's next for Velo 3D?
I guess I'll go first. I think the ask that we get every time we come out with a new platform, right? We just had the XC1MZ. People always just want to go. Customers want to go faster and bigger, right? And so, generally speaking, I think that seems to be the prevalent direction.
I think for me, from my viewpoint, what's next, especially like within the next 5 years, I'm looking forward to increased AM industry adoption, just more adoption by like the conventional manufacturing industry of AM, especially as we're making such great strides in part certification and qualification and standardization.
And Carlo, 30 seconds or less, what's your next priority? What are you looking to do next with AM?
First, I'm looking at AM to prove that the promises that has been made over the past number of years are true. So we need data, and we are data decision-driven organizations. And if this data will be confirming these promises, we will be ready to implement the digital warehousing concept in the real world.
All fantastic answers and definitely a bright future with everyone in the community working towards those. So I'd like to thank everyone for joining us. Thank you to our sponsor, Velo 3D, and thank you to Carlo de Bernardi from Conoco Phillips for joining us. See you at our next AM webinar, everyone.
Thank you. Have a good day.